Welcome to this lesson on ER modeling. I'll be making several videos on databases, specifically relational databases. In this example, we'll look at the company database. So we're going to design a database that will consist of departments, projects, and employees. So first, we need to create a database schema design based on the following. Okay, so the company is organized into departments. Each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations. Each department controls a number of projects. Each project has a unique name, a unique number, and is located at a single location. The database will store each employee's social security number, address, salary, sex, and birth date. Each employee works for one department, but may work on several projects. The database will keep track of the number of hours per week that an employee currently works on each project, and it is required to keep track of the direct supervisor for each employee. Each employee may have a number of dependents. For each dependent, the database keeps a record of its name, its sex, its birth date, and the relationship to the employee. So take a second here and pause the video and think about how you would design this database based on the scenario that we've been given. Okay, here's what the final ER model will look like. We'll have an entity for employee with several attributes that has a relationship type works for with department and shares another relationship type manages with department. Now the works for relationship type is going to be one-to-many, and the manages relationship type is going to be one-to-one. We'll also have a recursive relationship for supervisors. If you look at the supervision relationship type, an employee is managed by another employee. So this relationship would be recursive. And then we'll have a weak entity type for dependent. Since we don't have any way of really identifying this with a unique value, we'll have an identifying relationship type of dependence of with employee, and that'll be a one-to-many. We also have a many-to-many relationship, works on, that's shared between employee and project. Other than that, the strong entity types that we have in this diagram are employee, department, and project. Last but not least, let's identify this relationship. Department has a relationship type controls with project, and it's a one-to-many relationship. Let's talk about entities and attributes. An entity is a basic concept for the ER model. Entities are specific things or objects in the mini world that are represented in the database. For example, the employee John Smith, the research department, the product X, and project. Attributes are the properties used to describe an entity. For example, an employee entity may have the attributes name, social security number, address, sex, and birth date. A specific entity will have a value for each of its attributes. For example, a specific employee entity may have a name of John Smith, a social security number, 1, 2, 3, 4, 5, 6, 7, 8, 9, and an address and a sex and a birth date assigned to it. Each attribute has a value set or data type associated with it. For example, the name John Smith is a string. We could set the social security number to a large integer. So each one of those has a value set associated with it. When you're designing entities and you're writing out their attributes, this is a common practice. You typically make a node. For example, we have an example employee E1 with the attributes name, address, age, and home phone number. Then we have another attribute. We have another entity company with attributes name, headquarters, and president. Let's break down the notation for ER diagrams. So if we have a rectangle box, that's going to represent an entity, a strong entity type. An oval represents an attribute. A diamond represents a relationship. That's a relationship type. And then we use lines to link attributes, entities, relationship sets, entity sets. We use multi-circled ovals to represent multi-valued attributes. And anytime that we see a dotted oval, that's a derived attribute. Double lines connecting relationships, that is a total participation of the entity. And then if we have a rectangle with another rectangle around it, that's actually a weak entity. So that's the difference between a strong entity and a weak entity in a diagram. And then we'll use double diamond outlines for weak relationships. That's the difference between a regular relationship type and a weak relationship type in an entity diagram. Anytime that we see an oval connected by multiple ovals, that's a composite attribute. And anytime that we see an oval with an underlining an attribute name, that represents a key or single valued attributes. So jump into the conceptual schema design for the company database. So based on the schema requirements, we can identify 4 initial entity types in the company database. We know we have a department, a project, an employee, and a dependent. We can draw these entities, add their attributes, and we should end up with the following diagrams. So we have a multi-valued location, a key name, a key number, another property attribute, manager, and another attribute, manager start date. We can follow that same pattern for all of the other entities as well. Now I'll introduce relationships. So the ER model has 3 main concepts. Those are entities, attributes, and relationships. A relationship relates 2 or more distinct entities with a specific meaning. For example, employee John Smith works on product X project, or employee Franklin Wong manages the research department. Relationships of the same type are grouped or typed into a relationship type. For example, the works on relationship type in which employees and projects participate, or the managers relationship type in which employees and departments participate. The degree of a relationship type is the number of participating entity types. Both managers and works on are binary relationships. Relationship type versus relationship set. So a relationship set is the state of a relationship. A relationship type is the schema description of a relationship that identifies the name and the participating entity types. It also identifies certain relationship constraints. In ER diagrams, we represent the relationship type as follows. It's a diamond-shaped box and is used to display the relationship type. It's connected to the participating entity types by straight lines. By examining the requirements of the 6 relationship types that are identified, all are binary relationships, and we have them listed below. So we have the works for relationship between employee and department, the manages relationship between employee and department, controls between department and project, works on between employee and project, supervision, that's between employee and employee, it's a recursive relationship, dependence of, that's a relationship between employee and dependent. We can see those shown here. So we can look at the works for relationship, that's between an employee and department. Manages relationship is between an employee and department. The works on is between employee and project. Controls is between department and project. Supervision is a recursive relationship. And then dependence of is between employee and dependent. So constraints on relationship types are also known as ratio constraints. We can see those listed on the diagram here. We have the many-to-many, which is it's going from n employees to 1 department, or we have 1 employee manages 1 department. So we call those cardinality relationships. So we have a 1-to-1, 1-to-many, and a many-to-many. Here's an example of the managers relationship. So we have 1 employee managing 1 department. Here we have 1 department linked to many employees. And here we have many employees linked to many projects. So a relationship type between the same participating entity type in distinct roles is known as a recursive relationship. It's also known as a self-referencing relationship. We see this in the employees entity. We have a supervisor who's an employee, but their relationship to the other employees is that they supervise them. So it's a recursive relationship. Here's an example. So an entity that doesn't have a key and that is identification dependent on another entity type is a weak entity type. Weak entities must participate in an identifying relationship type with an owner or identifying entity type. Entities are identified by a partial key of the weak entity type, the particular entity they are related to, and the identifying relationship type. So an example is the dependent entity. It's identified by the dependent's first name and the specific employee with whom the dependent is related. The name of the dependent is a partial key, and dependent is a weak entity type. Employee is its identifying entity type, and that's shared via the relationship dependent of. So we have a notation that we follow for constraints and relationship types, the cardinality ratio. So it's shown by placing appropriate numbers on relationship edges. And we have the participation constraint as well. So there's the total participation constraint or partial participation constraint. And the total is shown by a double line and partial by a single line. So they're really easy to specify when it's a binary relationship. We can also use min-max notation for relationship constraint notation. So a department has exactly one manager and an employee can manage at most one department. So we can specify 0 to 1 for participation of the employee manages. Maybe the employee actually participates, or maybe the employee doesn't participate at all. And then we can specify 1 to 1 for the participation of department and manages. If the department's being managed, it's being managed by an employee. And we also have an employee can work for exactly one department, but a department can have any number of employees. So we specify a min of 1 and a max of 1 for participation of the employee in the works for. And then we can specify a min of 0 and a max of n for participation of department in works for. Here's an example of what that looks like in a diagram. So here's a summary of the notation that we have for ER diagrams. If you just want to take a second to go through and look at this and review everything that we went through in this lesson. I hope you enjoyed this lesson and keep on learning about databases. Thank you for watching.